Welcome to this tutorial on using the PIAC International databases. In this tutorial, we will show you how to combine data from across countries and how to work with it. The first question that many people ask is, can we combine data from across countries? And the answer is yes. But be careful on how you do it and the interpretation of the resulting statistics. Some of the things to consider are that each country has its own sampling design, stratification, clustering, number of replicates, etc. And while many are common across countries, these could vary. The PIAC technical report has this information for each country. To look up this information, see Table 15.6 in the PIAC technical report. And here we have Table 15.6 from the PIAC technical report, where we have the countries and the replication method used and the number of replicates used within each country. Notice, for example, the US had 45 replicates, whereas most of the countries had 80, except for Australia and the Russian Federation. So here we have the formulas to calculate the sampling variance, which we have taken also from Chapter 15 of the technical report. And we'll see that the way that the variance is calculated, we sum the differences between the replicates, square them, and then multiply them by a factor, here called f. And depending on which sampling variance estimation procedure is appropriate for the data, the value of f will change or will differ. So this value will differ by country, even if the accumulation of the differences across the countries is done using the same procedure. So what to do? It ultimately depends on if you can use the same variance estimation procedure for all the countries in your set. You could simply create one big file combining the countries and work with it. But if they use different variance estimation procedures, you need to divide and conquer by first calculating the estimates for each country and then combine these estimates accordingly. Regardless of the circumstances above, you will need to consider the contribution of each country to the combined estimates. When it comes to deciding how much each country should contribute to a statistical estimate, there are several options, but here are the two most useful and popular ones. Number one, each country contributes the same, which means that the results are those of an average OECD country. And the second one is that each country contributes proportional to their population. The results are then those of an average OECD adult. How do you control for the relative contribution of each country? You make use of sample weights. Sample weights are explained in a separate video. In this example, we'll show you what happens depending on how you decide to combine the different countries. So we have three countries, one with different population sizes, 327 million, 129 million, 38 million, different sample sizes. Also notice the bigger country has the bigger sample size. In this case, we have to calculate the average of something. This could be a proficiency. And if they all have the same average, then the averages, regardless of how you weight the different countries, will not matter. But let's say that we have now the biggest country scoring an average of 600 and the smallest country scoring an average of 400. So now we see that the different averages, they're not the same. So let's take a look here at the formula. When we calculate the simple average, we simply add them up and divide by 3, and we get the average of 500. When we calculate the simple average in a different way, what we're doing is we're using these things called the Senate weights. And the Senate weights, what they attempt to do is provide each country with equal contribution. So in general, the Senate weight gives you the same number as the simple average. But we'll show you in a later slide that this is not always the case. Now we can weight by country, and we'll see that here we're actually weighing the results by the population size. And as you'll see there, the result weighted by country is going to be dominated by the largest country. And therefore you will get a mean that's going to be above 500, whereas if we weight by sample, the average is going to be dominated by the country with the biggest sample, even though it is the smallest country in this combination of countries. So it matters how which weight you use to weigh the relative contribution of each country. So in the previous screen, we talked about the Senate weights. These are weights that are made to add up to a constant within each country. While the Senate weights can be very useful when working with overall country estimates, they are sensitive to missing data and differences in the distribution of cases by subgroups, as we will see in the next example. Now we want to show you some of the challenges of using Senate weights. So here we have the same three countries we had before, A, B, and C. We use a Senate weight. Each country weighs has the same average, and we look at the formula here. So the average of across the three countries is 500, and we see that the differences, regardless of whether we compute them using a simple average or a weighted average, because they're the same, there's be no difference. But now let's say that we have country A has 600 average, 600, and country C has 400 average, 400 average. So we see here, before we get to the end, we see that there's no difference, no difference, no difference between groups A and B. The simple average gives us no difference. But when we do this, the averages weighted by the Senate weight, we'll see that there are some differences. And the reason for that is that the Senate weights, the percent of people by group, by country is different. It's not the same across the country. So here you have that the average here for this something is lower than 500 because we have fewer people from this country that scores the highest. Again, the moral here is that when using Senate weights, they're good to be used at the overall level for overall country statistics, but once you start trying to use the Senate weights by subgroups within countries, there are two things that are going to affect the results. One is the incidence of missing data across the different countries, and two is the marginal distributions of the people, the frequencies of the people in the different groups that you use to divide your sample. Some final recommendations in terms of combining country data. First, decide which is your population of interest. Is it going to be an average adult or an average country? Combine the data sets accordingly and use the proper sampling weights. And then divide and conquer, which allows for the most flexibility. By this, we mean compute estimates for each country and combine the country estimates according to the corresponding formulas, which we will show you next. So now we will show you the formulas that you would need to use. First, if you are computing what's so-called an international average or an average across the different countries, and they all contribute the same, you simply add the estimates and divide them by the number of countries. The standard error of that estimate is going to be the sum of the variances of each of the countries divided by the squared number of countries. This will give you the equivalent of a Senate weighted statistic, which means each country contributes the same. If you want each country to contribute proportional to some other number, like this population size, you would then calculate the country statistics for each country and then do a weighted sum of those statistics divided by the sum of the weights. And to calculate the standard error of that estimate, you would do the weighted sum of the variances divided by the sum of the weights squared, as the formula shows. Thank you for watching. For more information or comments about these videos, please write to egonzalez@ets.org. Thank you.
This video was made possible by the Institute of Education Sciences of the U.S. Department of Education, through Grant R305B160020 to Educational Testing Service. The opinions expressed are those of the authors and do not represent views of the Institute or the U.S. Department of Education.